Hey everybody, welcome back to Organic Chemistry. My name is Todd Rothman, and in this section we're going to cover the acyl halides and acid anhydrides. Now I want to point out that for the rest of these videos we're going to focus in on specific class 2 molecules, or more than one. Like in this case we're focusing in on 2 of them. And basically we're going to learn the reactions using our foundation that we built up to now. So section 1, we built up a real strong foundation that's going to carry us for the rest of the videos. But what we're going to see here is that each functional group has a little subtlety to it, like something that you got to just remember, or little subtle details about them. Okay, so let's get started. Let's talk about number 1, the acyl halide. And by the way, after we do that, after each video set we'll do problems related to it until we get to the end. Okay, so the first thing is number 1. Let's talk about, I guess I'll write Roman numeral 1, acyl halides. So acyl halides, now 2 things to talk about. First off, how do they react for something new, like based on new material? And then also some of the things we talked about from last semester or even last exam. Okay, so the first thing is, let's talk about the new stuff. So an acyl halide, if you remember, can become everything below it. Remember, you have to have this little diagram, right? Like this little diagram where you have acyl halide, acid anhydride, right? I hope that you're saying it to yourself. Believe me, when you do this, you have a card, so you're allowed to kind of put it on your card. But when I took the class, I didn't have a card, and I would just keep writing this out to myself. So sulfur, right? The thioesters and the thioacid. Your ester, carboxylic acid, and amides. Okay, so what we note here is that the Cl, which is where we're at now, this can become everything below it. And so let's go ahead and figure out how to do that. Well, for the first one, if you want to turn it into an acid anhydride, then you have to use a carboxylic acid, right? So think about it. If I want to become this, what I'm really trying to bring in is this piece here, right? That's it. Now it turns out that because this is the very top of our list, I'm going to write this here. There's no catalyst or promotion required. Sorry guys. Or promotion required. So you don't need a catalyst, because these are such great leaving groups, Cl, that these as in halogens I'm referring to. So Cl or Br is the 2 common ones. X could be Cl or Br. Not to say that it wouldn't work with I or F, but they're not as popular as these 2. These are the 2 that we tend to see. So these 2 here are the most common. But don't worry, if it's fluorine, then it work it as well. But usually these are the 2 that I've seen. I've never seen a fluorine or an iodine, acyl iodine. It's usually chlorine or bromines. Okay, so if you have an acyl chloride or bromide, then what we're going to do is there's such great leaving groups that you don't need an acid. You don't have to protonate the O. It doesn't mean that you can't. You could, but you don't have to, is what I'm saying. Okay, so you can either have this as a negative, O minus, carboxylic acid. You could have it as a neutral, like that, or you could have it with H plus and carboxylic acid. That's my point. It doesn't matter which way you do it. So I'm going to do the most common way. I like this one the best. It's the fastest pathway to draw on paper, where it's a negative. So this comes in, and this opens up, and you get to your intermediate, right? O minus. Now we're going to follow our template. That's all we're going to do right now, and we'll get to this point. Now I want to point out that even if this was neutral, then all you would do is you would just bring it in, right? If this was carboxylic acid, then this would be positive like that. And I guess I should, well, I'll use the next one as an example for that. So for this one, I'll leave it negative. I'll kind of show you all the variations, okay, through each example. So here it is, so it's not negative. And now when this closes down, then of course the Cl is the better leaving group, so it leaves. And you get to your acid anhydride. And that's it. So that's how you turn it into an acid anhydride. So the first one, acid anhydride. And as you can see, it really is the same template that we've been describing. Whoops. Over and over again. So I'm going to write 2 acid anhydride. Okay, that's the first one. Okay, now this is an independent idea on all acyl halides. Okay, so this is A. Now B, let's talk about converting it to, down below the acid anhydride is the ester. Now I'm going to skip over the thioesters and the thio in general. It's just a sulfur version of whatever the oxygen is, so it's really the same thing. So let's say we want to bring it to an ester. So now we take an acyl halide, and again, it does not matter, right? This is a universal. Notice how it's not in any one section. No catalyst is needed for any of these. Okay, so what I mean is I can have it where it's just methanol without the acid, or without base version of this. Okay, just methanol, and it works fine. Okay, and I'm going to show you this one for a reason. So this is neutral, but again, if I had H+, then you use it, right? You're going to protonate the oxygen first and then bring it in, and I'll show you that pathway as well. So we did a base example. We'll do a neutral, right? And let's say this comes in, and this opens up. And again, the reason why is because Cl is such a great leaving group, and it's such a weak bond to the carbon here that this carbon is very positive. You don't need any promotion or any catalyst. So we have an O minus, we have an O with a CH3 and an H. It's positive, right? And Cl. Now here's something I mentioned to you in the theory video, the template. Remember I said positive is always better leaving group than neutral? Well, that's not true with halogens. Halogen is actually a better leaving group, even now. So what actually would happen if this closed down and we don't transfer a proton because this Cl doesn't want any more bonds. It has already its one bond that it needs. So there's no proton transfer here. But when this closes down, instead of the O leaving, which you would normally think is a better leaving group being positive, it's not. Halogen is, right? So remember, SN2, E2, E1, SN1, so halogens, right? They're all leaving groups. So it turns out that this is a great leaving group, even neutral. Okay, and so now we have this right here, and we have an OCH3 that's still positive. Now sometimes what people do, because of the next step, I'll show you what happens. Now we're just going to have that plus Cl minus, but the Cl is going to swipe that proton. It's going to pull that proton off. And now we get to a neutral ester plus HCl. See that? So that's what happens. So sometimes people, in order to skip this last step, you might set it up a little bit differently, your drawing. So I might have drawn it out like this, where this is the OCH3, and this is the H, so that I can actually make it pull the H while it's leaving. So I can go like this, almost like it's leaving and pulling the H at the same time, right? And so now I can go right to the end without showing this part here. Okay? So I'm not going to do that since I didn't already. So, but now you see it. I'm going to go back to how I originally had it. Cool. There it is. Okay, so we're back to the original. So you'll see as we go through problem solving throughout the rest of the videos that I'll do some tricks along the way to kind of make it easier on paper. But here's the full path. All right, so that's the ester. And again, if this was a thioester, then just put an S there, and that's the only difference. Okay? And these can happen with acid or base or neutral conditions. C. Let's talk about acyl halide to carboxylic acid. So we take this right here, acyl halide, we treat it with water, and again, this could be on the acid, base, or neutral, doesn't matter, right? Because in our case, it's a very good leaving group. So what I'm going to do is use the acid pathway. We didn't do that yet. So we did base, we did acid, we did neutral, now we're doing acid. And again, I don't want you to think that this is the only way it happens. It happens in any one of these variations for all of them. So this could have been water by itself. So if you protonate first, you get it activated, and now it's even more positive. It was positive to begin, now it's super positive. Now water is going to come in, and this is going to open. So we have an OH with a Cl and an OH2+, right? Because it's neutral when it comes in, so it's positive now. Well, when this closes down, again, the better leaving group is the Cl, the neutral. So here's that exception. Remember, halogens are better leaving groups than even neutral, than even positive things. So you get to this right here, OH. Now, how are we going to handle this? Well, this is still OH2+, and this is plus. That's not good, right? So how would we handle something like this? We would never want to show positive twice. So this is a good hint for you and for me to show you. Well, instead of having O positive twice. That's ridiculous. Let's stabilize first.